Everyone's, yes, continue. Good morning. Can everyone hear me? I hope so. All right. Welcome, everyone. Thank you for joining today's call. We will be starting in a couple of minutes to allow time for those still connecting to join. Our experts are excited to hear from you today. Please use the live event Q&A window to post questions and feedback throughout the call. We will do our best to get all of them live or in the chat. The Q&A feed is visible to all attendees. If you would rather post anonymously, you do have that option. As a reminder, this webinar is being recorded and will be available within a week on YouTube. And the link, we will provide that link for you. Last but definitely not least, please be respectful of your peers and our speakers. We are all here to learn and engage. So let's get started. For those of you still joining, welcome again, and thank you for joining today's webinar covering the evolution of Windows authentication. Your speakers today are Zach Whittington and Steve Seifus from our product engineering team. Zach and Steve are here to provide you with a deeper look at replacing NTLM in Windows and provide a sneak peek of upcoming changes to Windows authentication. With that, I'll sit back and enjoy the call with the rest of you. Over to you, Zach.
Am I coming through now? Can you guys hear me?
I can hear you.
The slides coming through as well?
Not yet. Now they are.
Great. There we go. Thank you for that introduction. Today we'll be giving you a sneak peek of upcoming changes to Windows authentication, including how we'll move away from an insecure authentication protocol, NTLM, and replace it with something tried and true, Kerberos. Today's talk will cover a brief introduction to the changing Windows authentication landscape. We'll look at an overview of NTLM and its modern problems and why it's still used today despite them. Then we'll introduce our solutions and how to use them, and finally wrap up with a sneak preview of future plans. Afterwards, Steve and I will be available for a technical Q&A alongside another PM from our team, Matthew Palco. First, let's talk a little bit about how the Windows authentication landscape is changing. Windows traditionally has three primary authentication protocols: New Technology LAN Manager, NTLM, Kerberos, and a protocol called Negotiate, or SP-Nego, which helps endpoints decide which authentication protocol to use in their connection. As we move toward the future of Windows authentication, we are focusing first on one major trend: getting rid of insecure NTLM and replacing it with new Kerberos functionality. Today, trillions and trillions of authentication messages are sent in Windows every day. We see this work stream as a multi-phase project. For this first phase of work, which is expected to be released in an upcoming version of Windows, our immediate goal is to empower you to identify and reduce NTLM from your systems. Our longer-term goal is to eliminate all usage of NTLM across the entire Windows ecosystem. So what is NTLM? NTLM is a classic challenge and response authentication protocol. Clients must prove they are who they say they are to a service, which then grants access to protected resources if the authentication was successful. The most recent version of NTLM, NTLM v2, was released in Windows 2000 almost 25 years ago, when it became the default Windows authentication protocol. A few years later, however, NTLM and Kerberos were rolled together into a unified interface called Negotiate, which has since been Microsoft's recommended authentication protocol of choice. Here's a quick overview of how NTLM works. It's a fairly straightforward protocol. When a client wants access to protected resources on a server, the server stops them and asks them who they are. The client responds with an encrypted message containing the original challenge, as well as their username and their password. The server checks that the username and password are legitimate and matched to one another, and if so, allows the client access to those resources. So what's wrong with NTLM? To begin with, NTLM unfortunately relies on crypto that is aged poorly. The response to the server's challenge is encrypted using HMAC MD5, which is in itself fairly secure. The problems come from its reliance on the weaker MD4 algorithm to hash the user's password into a secret key. If the output of MD4 were perfectly random, then NTLM's crypto would be much less of a problem. However, MD4 output is actually relatively low entropy, meaning it's comparatively easy for an attacker to guess the secret key. If the attacker wanted to simply impersonate the victim, they would only need to find a collision with the MD4 output. If they wanted to completely compromise the victim's account, they could take it a step further and attempt to crack the victim's actual password, which was fed as input into the MD4. Further weakening this scheme, the password input is not salted, meaning this packet can be captured on the wire and cracked offline or reused, such as in a pass the hash attack. As hardware power has increased over the years, these weaknesses have left NTLM vulnerable to attacks carried out on consumer-grade hardware. NTLM also lacks a concept of server authentication, meaning the client has no way to verify that they are connecting to the server that they intended to connect to. This situation can lead to relay attacks, where a malicious server inserts itself in the middle of a connection between a client and their intended target server. When the client mistakenly sends their credentials to the malicious server can cache the message and use it to gain access to other legitimate services. This effectively means that the security weaknesses of NTLM can be used to pivot and compromise different services and applications, even if they are otherwise insecure. NTLM is also inextricably tied to passwords as the only supported form of credential, and this design decision is unfortunately baked pretty deep into the protocol. While passwords alone may have been adequate in the past, the industry is now shifting to more modern and flexible authentication methods, and NTLM is unable to keep up. For example, NTLM is fundamentally incompatible with other forms of credentials such as certs, biometrics, multi-factor, and FIDO keys. As long as machines are relying on NTLM, they are also tied to the usage of passwords, which is a move in the opposite direction of most of the industry. Finally, over the decades, NTLM has accrued some problematic bugs, including those used in some recent attacks that have surfaced in the news. Overall, NTLM suffers from some fundamental design flaws, as well as crypto that is aged poorly. It's time to move on to something better. Unfortunately, though, NTLM has proven to have some sticking power. So, if NTLM is known today to be insecure and to have some fundamental design flaws, why is it still used so widely? There are several reasons. One reason is that NTLM is simple. It's simple both to implement and to use. It's straightforward challenge and response, meaning that you only need the two parties that are most relevant to the transaction, the person who requests the data and the person who has the data. It does not require a third-party central database. And another reason NTLM is used today is that users, admins, and customers may not be aware that they're using it or that they should be moving away from it. Or in some cases, they don't know how to move away from it. And finally, and most significantly for the design of our solutions, NTLM is used where Kerberos won't work. Let's talk a little bit more about negotiate and fallback. Microsoft's official guidance for the last several years has been to not use NTLM and instead use the negotiate protocol. When both ends of an authentication connection support negotiate, the first thing they will try to do is mutually agree upon the authentication protocol that both of them support and offers the best security for the situation at hand. It turns out, in about half of all cases, NTLM is used because negotiate first tries to use Kerberos or another protocol, but for whatever reason, the other protocol cannot be used, and negotiate falls back to NTLM. For this reason, NTLM is sometimes necessary today, and that's where our solutions come in. There are simply situations where Kerberos cannot be negotiated today. Some common examples include work groups, local users, and domain lists. Microsoft accounts doing machine-to-machine authentication, such as SMB or RDP, and legacy or misconfigured domains. In order for Negotiate to effectively end its reliance on NTLM, we need replacements for NTLM. So what should we use? We need ubiquity, we need better crypto, we need more extensibility, and we need FIDO, smart cards, and Windows Hello for Business. We need Kerberos.
Well, hang on. Previously, Zach just said that we can't use Kerberos, or there are scenarios where we can't use Kerberos because that is the reason the NTLM gets used. So clearly there is something that we have to do here with Kerberos. So one of the interesting things about Kerberos is it varies significantly from how NTLM works. First of all, it is the primary authentication mechanism that Windows prefers for a lot of different scenarios, especially in an enterprise environment. Back in 2000, when we first shipped it, it was built specifically because it overcame a lot of the problems that NTLM had. First of all, it has better crypto, so we're not looking at MD4. You may be familiar with RC4, which is something that we killed in a recent security patch last year, but that Kerberos gives us the ability to work through those problems. Another issue is that Kerberos also provides server authentication. So in the event that you have a heterogeneous environment or you are working through complex deployment scenarios, Kerberos allows you to guarantee that the thing that you're talking to on the other end is actually the thing you care about. Whereas with NTLM, you're at risk of attacks for things like relays and replay attacks. And one of the other more interesting things is because NTLM is primarily password-based, whereas Kerberos isn't, we can do things like bolt on additional credentials like Windows Hello, or in this case, pkinit, which is how Windows Hello works. And this is also how we ended up building in FIDO, and it gives us more opportunity in the future if we want to add more credentials. But the problem is, the way that Kerberos works is it has a dependency on something called a KDC, Kerberos Key Distribution Center. And so if we're just wanting to talk to an application, we can't. We have to first talk to a KDC. And the interesting problem with that is we always need to talk to a KDC. So we need to have line of sight. Now, I'm not going to go over how Kerberos works. I'll save you that. But at a high level, we want to talk about this idea that we have this thing called the KDC that is who proves you are who you say you are. So usually you have a password and you authenticate to it. You get something called the TGT back. And then anytime you want to go talk to an application server, say your SMB server, your RDP target, anything like that, you need to use your TGT to exchange that for a service ticket to that specific application server. So as a result, one of the fundamental requirements is before you even talk to the application server, you need to go talk to this KDC. And so we have this problem of line of sight. If I'm outside the corporate network, or if it's in a complex environment, one of the problems is firewalls, network topologies, whatever, don't allow you to actually access the KDC first. The only thing you can see is that initial application that you care about. And fundamentally, NTLM doesn't have this problem because the way that it works is it takes the messages and the application server that you're talking to will then forward that off to a domain controller. So how do we deal with that? That's a pretty interesting problem. Well, the introduction of, I should also say that that makes up about 5% of NTLM usage. Believe it or not, when we're talking about why things fall back to NTLM, line of sight is relatively small. Most people work with NTLM in an enterprise environment. But I'll talk about why that's important in a second. But first, we still have to solve this fundamental problem. And the way we do that is with a new protocol called IA-Kerb. Now, IA-Kerb is a RFC track standard, meaning that we're trying to get it through IETF so that there's it makes it an official extension of the Kerberos RFC. So Kerberos is RFC 4120. IA-Kerb will be an extension to that, so that it will be easily defined so that third parties can interop with it. So things like Samba and Apple and all Heimdall, all of these different third parties that do Kerberos one way or another. And the thing about IA-Kerb is it's actually relatively simple. When I say that it's an extension, what we're basically saying is we have this concept of Kerberos, and it works fundamentally similar. We're just kind of moving the chess pieces around. So at a high level, when we're talking about authentication, we have you. Did we just drop the presentation? Okay, well, that was fun. With prior to IA-Kerb, we had this problem where we needed to have line of sight. And this, in order for me to go talk to this application, I had to go talk to a KDC first. And that meant those messages. So I have the password, I do the TGT thing. With the TGT, I go and get a service ticket. All of that happens before I talk to the application. Well, with IA-Kerb, fundamentally, it works identically, except the messages themselves, instead of going over port TCP 88 to some domain controller, what's actually happening is those messages are getting bundled up and sent through a special encapsulated function of a protocol called SP-Nego, negotiate. And all of those messages, the ASREC, the TGSREC, all of those things get sent directly to the application server. And so your SMB server, your RDP target, whatever that is, then takes those messages and forwards those off to the KDC because that target server already has line of sight. We know this because it did NTLM in the past. And NTLM requires line of sight to a domain controller for the target. So it's sort of a relay in some ways, or a proxy if you want to think about it that way. So we send the messages through the application server. The application server doesn't really know any better. It's just seeing messages going across the wire, and it's just forwarding them somewhat blindly. And then they get sent back to the client, and the client ultimately ends up with this Kerberos ticket. It doesn't know that it talked to a KDC. All it knows is it talked to an application server. So we've solved that line of sight problem. So the other problem is local users. Local users make up 29% of NTLM usage. That's a huge jump over the 5% of NTLM usage for line of sight issues. But the idea of a local user is exactly what it sounds like. I have an application server, and on that application server, I have a user. And that user is authenticated directly by the application server. It's as simple as that. There is no KDC. There's no backend service that goes and authenticates you. And NTLM makes up 29% of all of those authentications in Windows. So that means that in order to kill NTLM, in order to deprecate NTLM, we need to figure out a way to solve that for local user accounts. We can't just turn this off. Otherwise, there will be all sorts of problems in all sorts of environments because so many environments rely on local users for authentication. LAPS, the local administration service that we shipped sometime last year, that takes a huge dependency on local user accounts, even in an enterprise domain environment. So how do we actually solve that problem? Well, it turns out we have this thing called local KDC. And one of the interesting things about Kerberos is fundamentally it's just a protocol. Kerberos is, I wouldn't say it's simple, but it is actually, the constituent parts of it are relatively simple. You have a client, you have a KDC, and then you have the target server. Well, there's nothing that actually says that the KDC and the target server actually have to be different. They could actually be one and the same. So what happens if I send Kerberos messages to the target server itself, and the target server just verifies those Kerberos messages? Turns out we can do that, and that's what we're doing. What we're doing is we're taking the enterprise domain controller KDC code, and we are dropping it on every single Windows server or client, as it were. We are making it into anything that is accepting messages is a server in this case, and we're putting it in all Windows machines so that they can accept Kerberos messages against the local security authority. And the local security authority is where all of those local user accounts live. Now, one of the problems with Kerberos, and it's not really a problem so much as it's just a design decision, but in this case, it is a problem because Kerberos historically operates against port 88 on over the network. And that has interesting problems because you have things like DNS name resolution. How do I find a domain controller? And then you have networking and routing and then realms and all sorts of complicated things that sort of dictate all of these problems with Kerberos. We're taking all of those out of the picture, and we're basically saying no matter what, you have to do it over IA-Kerb. So if you're doing IA-Kerb to a target server, we'll determine, are you doing this to a local account, or do we need to forward it off to a full domain controller? No networking required, no DNS resolution, nothing. We'll figure it out. Now, lastly, if we do the math, we look at IA-Kerb, local KDC, those account for what, 34, 35% of NTLM usage. There's this large chunk of NTLM usage that falls into a scenario that we can't do anything about, and that's the unknown server bucket. That makes up 14. And so that gets us to like 48, 50%. The numbers fluctuate on a regular basis, but that's what we're looking at. And this unknown server problem is actually sort of this fundamental security issue. And the fundamental security issue of an unknown server is if I don't know who I'm talking to, then that means that I'm sending things to a server that I don't necessarily trust. Now, Kerberos solves this problem. Kerberos knows how to authenticate to a server, and it knows how to prove the identity of that server to the client. But the problem is, if Kerberos can't do that for some reason, we fall back to NTLM, and NTLM doesn't care. It just sends the message, which is, how we end up in the issue of relay attacks and things of that nature. Well, Kerberos can't solve this problem, or at least it can't solve all of these problems. And if we look at what 14%, if we look at the 14% number, those fall into two separate buckets further. First of all, we are doing an unknown, we're trying to connect to an unknown server because it's using an IP address. Historically, Kerberos really only likes domain names or fully qualified names, things of that nature that are, identifiers. IP addresses aren't really useful identifiers because they're generally ephemeral in nature. They change fairly regularly. And the name has stopping power. So if you're trying to connect over an IP address, Kerberos by default will say, no, we're not doing Kerberos. We're just going to do NTLM. And that makes up 5-7%, give or take. And then we have this other problem of if we're talking to a server with a misconfigured name or something like that, the server, when we're trying to go get a ticket to that server, we're sending the domain controller a name it doesn't understand. It says, no, I don't know who that is. And that makes up another 5 to 7%. And that's how we get the 14%. Well, half of those, we don't know who the name is, we can't do anything about. We're not going to do anything about it. That's a security issue. And so 7% of NTLM usage, we can't do anything about. That is something that we hope to allow customers to deal with in a auditing and observation period, so that users can look through this and find, okay, I know that these applications aren't configured correctly. We'll get them over to Kerberos. We'll get the names. We'll get the SPNs. We'll get that figured out. In the IP address case, we actually already have a solution for that. We have some registry keys and we have some policies that allow you to control whether or not an IP address can be used for Kerberos, and that just requires registering an SPN. So as a result, we end up getting to, what is that, 41% of NTLM usage solved outright. And then we have this little bit of 7%. Now there's an interesting problem though. We're at 48%, and it turns out that 52% of all NTLM usage is because applications have this tendency to hard code the usage of NTLM. That's unfortunate. That means that there's nothing that we can do about it at a high level. We can't just change it on the fly for applications. That just breaks things. We have compatibility issues with doing that. We can't do that to customers. That's a non-starter. But it turns out that when we dig into who is hard coding it and why they're hard coding it, we can actually change this a little bit. We can say that for applications that we own, Windows, Microsoft as a whole, we can change those over to negotiate. We can say at that point in time, applications built into Windows, things like Windows services, print spooler is a big one, RPC services that have silly defaults, things of that nature. We can change those. And that'll actually bump up the numbers quite a bit. So that'll move from the 48%, and that'll actually push it upwards of 80%. So 80% of all NTLM usage will eventually, by the time we're done with this, just disappear through the nature of these changes. And with that, I'll hand over back to Zach so he can talk a little bit more about how you end up using all of this fun stuff.
Thanks, Steve. So how can you actually use these new solutions to get your organization off of NTLM? IA Kerb and local KDC are planned for release in an upcoming version of Windows. If you're interested in this space, keep your eyes open for upcoming blog posts and announcements as we publish more information about these tools. But once it is released, how do people use it? Do you need to install a bunch of new stuff? In most cases, no. IA Kerb and local KDC will be delivered as sub-protocols within the existing Negotiate protocol. We decided to do this for a variety of reasons. Most notably, Negotiate is already present on all modern Windows devices. Negotiate has been the official Microsoft authentication guidance for over a decade. And most significantly, from a design perspective, Negotiate includes built-in fallback. Once these features have been released, the typical setup of Negotiate in a Windows environment will try 3 authentication protocols. First, it will try Kerberos. If for whatever reason Kerberos cannot be used, it will fall back and attempt IA Kerb, which includes within it local KDC when relevant. If IA Kerb and local KDC cannot be used for whatever reason or otherwise fail, Negotiate will finally fall back to NTLM, thus reverting back to the status quo today. All right, so if the features are coming in Negotiate, how do customers actually use them? Well, that depends heavily on what their authentication setup looks like today. Management and usage of these features will fall into three broad buckets. The first and the easiest scenario is for anyone already using SP-Nego to negotiate authentication, according to Microsoft's best practices. This audience will automatically benefit from this change when they update their systems, requiring no additional installation or management. It should just work out of the box. Once updated, SP-Nego will automatically try to use IA-Curb and local KDC when relevant and possible. However, because fallback to NTLM is still preserved at this stage, in most cases, we expect no major interoperability issues. However, we are aware that NTLM is used today in a hugely diverse array of scenarios, and there will be some exceptions with interop or compatibility issues. We welcome community feedback both during this talk and offline. The second scenario, which is almost as simple as the first in most cases, is if NTLM has been hard-coded as the Windows authentication option to use. In the vast majority of cases, these situations should be as simple as replacing the string NTLM with the string negotiate. Quite literally, in a lot of cases, you can just change this one value and the connection will switch from always using NTLM to instead using negotiate and thus avoiding NTLM whenever possible. The third and final scenario, which will require more heavy lifting, will be situations with interop between Windows and non-Windows systems. In order for Negotiate to decide to use IA-Curb, both ends of the connection must have implemented IA-Curb or know how to interoperate with it. The same goes for local KDC. When both ends of the connection are updated Windows machines, this will require no additional work, but it will require some work to integrate with non-Windows implementations. Given this interop concern, it is important to emphasize that fallback to NTLM will continue to be available for now. This means that, for now, if non-Windows implementations do not understand IA-Curb and try to connect to an updated Windows systems, we expect no breakage, and in many cases, expect the connection to settle on using NTLM. That said, NTLM is on its way out, slowly but surely. Eventually, NTLM will no longer be a supported option in Windows, and the fallback to NTLM in most cases will not happen. The maintainers of non-Windows implementations of Negotiate or related authentication protocols should start thinking of ways to move off of NTLM if they have not already done so. While we expect most interoperability issues from these changes to be mitigated by fallback, we are also providing a selection of management capabilities to allow admins more fine-tuned control over this change. First, it is possible to audit and to some extent control your NTLM usage in your environment today, using existing tools published by Microsoft. The auditing capabilities can help admins get clarity on which components of their systems are relying most heavily on NTLM. The same tools can also be used to selectively prohibit various versions of NTLM. For example, prohibiting only NTLM v1 in your network. There are also configurable options to block either all NTLM traffic or only incoming or only outgoing traffic. We will also be expanding these auditing capabilities as we roll out more NTLM-related tools. Second, IA-Curb will be rolled out with per-device configuration options, including both allow and deny list configurability. For example, it will be easy to set this feature broadly turned off across an environment while toggling it on for select test devices. Conversely, if admins identify specific machines, for example, a certain file server that may have compatibility problems with these changes, they can turn off the changes for only those machines while leaving it enabled elsewhere. Similarly, there will be per service configurability, again with both allow and deny lists. If users encounter issues with any particular service or set of services, such as SMB, RDP, HTTP, etc., they can choose to exempt those services from these changes. Finally, the entire IA-Curb and local KDC change as a whole will be toggleable via group policy. This high-level backout is a standard option for most modern Windows features, and will help give some customers and partners the time they need to mitigate atypical compatibility and interoperability issues. However, it is worth emphasizing again that NTLM is ultimately on its way out, and that businesses shouldn't simply disable this feature and forget about it as a long-term solution. Eventually, fallback to NTLM will no longer be an option by default in Windows, and any organization that expects to be unduly impacted by this should start planning ahead now. Speaking of which, let's talk a little bit more about where we're taking our NTLM-less project. As alluded to previously, this current work, IA Kerb and local KDC, is just phase one of a much longer term project. The deep legacy of NTLM in both Microsoft and non-Microsoft systems means that we can't simply rip out NTLM overnight, no matter how many viable replacements we can build. We have decided to use a data-driven approach to inform our strategy and timelines, giving customers and partners enough time to adapt to each phase before moving on to the next. This first phase is a necessary prerequisite for the larger scope of work, since there needs to be some alternative to NTLM that can be used in its place. Today, the capability to simply and totally disable NTLM within a Windows environment does technically exist. However, because NTLM is necessary in some cases where other protocols can't be used today, in practice, the setting tends to just immediately break a lot of things. Thus, until we can provide usable alternatives to NTLM, admins will have a tough time moving away from it. The multi-phased approach of our strategy will allow organizations to move faster or slower than others to fit their security needs. Once the NTLM replacements have been adopted in updated versions of Windows, we will move to disable NTLM in Windows by default. During this second phase of things, Windows devices will never allow NTLM to be used in either incoming or outgoing connections unless an admin has explicitly re-enabled it. The vast majority of organizations should notice no change at this point, other than the reduction in NTLM usage. Any organizations that experience problems when disabling NTLM will still be able to turn it back on easily using group policy until we move to our final stage of phase out, which will involve the removal of NTLM from Windows by default, potentially being provided as a separate feature on demand. The timeline for this last phase is to be determined, but will be adequately spaced out to give customers the time they need to prepare. That date, however, is ultimately coming someday, and we're using this opportunity to let people know that it's time to start thinking seriously about moving away from NTLM. Here we've included some resources, including documentation and public specifications of some of the features discussed today. There will be more information released about this project in the coming months, so stay tuned for more talks, blogs, and other announcements. We wanted to conclude by mentioning that we are actively seeking community feedback at this point. So if you have any questions, cares, or concerns about this plan, please speak up in the Q&A or email us at ntlm@microsoft.com. Thanks again for coming to our talk.
Thanks, folks. So we have a ton of Q&A, lots and lots of questions. Tried to answer as many as I could while Zach was talking. Want to go through some of them, make sure that we're talking about them broadly. Let's see. So one of the questions was IA Kerb KDC proxy. I covered this in the technical description of how IA Kerb works. KDC proxy works. KDC proxy is fundamentally just moving the messages that go over port TCP/88 over HTTP and TLS. So you still need line of sight. The difference is the client will connect to KDC proxy and then from the KDC proxy to the domain controller. Whereas with IA Kerb, all of those messages will route through the application in question. So the SMB server itself or the RDP server, something like that, or RD gateway more specifically in that particular case. One of the other questions in similar vein was remote desktop services or RD Gateway currently only works with NTLM. That's actually not true. Those services currently work with Kerberos just fine. The issue that a lot of people run into is they are inherently external facing services. You have this RD gateway that is sitting on an open internet or on the open internet or through a partial VPN, something to that effect, where the client generically does not have line of sight to a domain controller, so they can only do NTLM. That's fundamentally why we built IA-Kerb, so that we can do these things. RD services, gateway, things like that will inherently be able to adopt IA-Kerb. It'll be transparent to them. They just don't know any different. As long as the client understands IA-Kerb, as long as the gateway understands IA-Kerb, this will work transparently. Let's see, what else? Inventory usage of NTLM usage at an enterprise level. We actually, back in the Windows 7 days, we shipped a whole suite of auditing and event logs. Ned Pyle has a wonderful article. It's going on, over a decade old at this point, but it's still a fantastic example of how you can do this. And because they're Windows event logs, you can aggregate them at central level, either through the domain controllers, pulling everything in. You can use Windows event collection services. You can use third parties to aggregate all of that information. But we definitely heard from a lot of folks that those auditing events don't necessarily include certain pieces of useful information, trying to understand who the application owner is that is doing this. We'll tell you the process ID, process 123. Great, that process, was launched 3 weeks ago. How do we know what that one is? We're moving towards things where we're actually telling you the EXE and things like that. So we're improving the auditing information so that we can bundle all of that up to you. Let's see. For Kerberos, don't we have to be on-prem? Well, yes, technically that is true. I did build Kerberos into Azure AD or Entra ID at this point, going on 2 years ago. So that's a pretty good example of why Kerberos is sticking around. Because it has a whole bunch of utility. We can make Kerberos work in the cloud. The fact that we are able to make Kerberos work in the cloud sort of points to the fact that it has a whole bunch of utility in all sorts of different scenarios. Does Kerberos allow me to reference servers via alias names, or do soft fails become hard fails? Aliases are actually dangerous. When I'm talking to server A, or when I type in whack A, server A, and it's actually aliased to server B, and then behind the scenes everything authenticates as B, from my perspective, the system lied to me, because I'm not actually talking to A, I'm actually talking to B. So aliases are potentially dangerous in some scenarios. And as a result, we don't really want to expose that further. We don't want to introduce that behavior. If you're going to create an alias, there are ways to do it correctly. So you do have the security guarantee, but we're not changing anything in that regard. The behavior will still stay the same. It's if you have an alias and it's not configured correctly with the right SPN, you're going to have a bad day. Does this impact logging into a laptop with a domain controller with a domain account off VPN? Short answer is no. This concept is intended for directly connecting to applications. It turns out that there's nothing inherently problematic with connecting off the network, or logging into a machine off the network and then connecting to remote services or remote applications and authenticating using Kerberos. That'll just work. The issue that you run into is scenarios like group policy and management services, whether it's built into Windows or it's a third party. That's a different problem. Those aren't authentication problems. Those are, how do these protocols, whatever they are, group policy or your management services, how do those connect? The magic word there is orthogonal. They are not related to one another. If those services work outside of a VPN environment, great. We will happily do IA curb over those, but that's not really related. You still need line of sight to a domain controller in order to do group policy, for instance, because it's just not authentication related. Have you met our friend Azure AD Join, or in this case, Entra ID Join? That solves a lot of those problems. You can have MDM remote management from the cloud. Works great. Let's see, what else do we have? Kerberos is vulnerable to techniques such as Kerberos sting. Is Kerberos considered more secure because of the relative difficulty of this type of attack? Short answer is actually yes. As Zach alluded to early on, the cryptographic properties of NTLM make it incredibly weak, and so anything is better than that, with the exception of the RC4 cipher suite in Kerberos. And so in that regard, yes, Kerberos is better, period, full stop. Kerberos is affected by attacks like Kerberosting. The solution to those things, those types of attacks, are, as Matthew pointed out, weak passwords are sort of the bane of our existence. There's nothing that we can do about a weak password. A weak password is just impossible to solve for, and so we want to move towards more better credentials like Windows Hello, FIDO, things like that, where they are both unphishable, unguessable, yada yada yada. But even if you do still continue to use passwords and you do continue to use weak passwords, we can at least make it harder to break. And we can, the name of the game here is the amount of time it takes to actually compute a password hash. And with Kerberos, because we have this crypto agility, one of the abilities to replace cipher suites, I wouldn't say on the fly, but certainly in a much simpler manner without customers having to know anything going on. It makes it a lot easier to introduce better, more secure algorithms, harder to execute hashes. So we will be improving that as time goes on. Right out of the gate with local KDC, for instance, RC4 is out of the picture. We're doing AES. If you have a local user account that was created, don't quote me on this, it was either 2012 R2 or 2016, one of those releases. We actually started upgrading user accounts to use local user accounts specifically to use AES. That incidentally was totally unrelated to this. It was because when you take a local server and you promote it to a domain controller, we copy the local administrator account to be the domain admin. So we wanted to have AES keys out of the gate for that. Knowing that TGTs are no longer provided to the client directly by a KDC, will application servers still send TGS tickets or only use the TG2? It's full Kerberos. You get a service, the application server cannot use a user's TGT. It just doesn't understand it, doesn't have the keys, doesn't have anything like that. So it's not going to do anything. So it's full Kerberos through and through, nothing changed there. It's the only difference is where the message is flowing. Does IIS currently support IA curb? Nothing currently supports IA curb. We haven't shipped it yet. Once we do ship it, yeah, they'll support IA curb. Let's see. We use one-way external trust to authenticate users into a resource domain. To use IA curb, would we need to switch to a different trust type? I don't want to go into too much of a rat hole here, but in general, we don't like external trusts. An external trust historically has been called an NT4 compatibility trust. If that sounds incredibly scary, it should be. There's no guarantee that it'll ever do Kerberos. It's just not designed for it. The fact that it can do Kerberos is more of a side effect. It was never intended for that. It was always intended for compatibility with NT4. So moving to a either a Forest Trust or an MIT Trust is going to be a preferred option. That being said, if for some reason the external trust is already doing Kerberos, there's nothing that would prevent it from doing IACurb. IACurb is a client application paradigm. It doesn't necessarily rely on the domain controller in question. From the domain controller's perspective, it's just seeing an application sending it Kerberos messages. It's transparent to the domain controller. Will a shift from NTLM to Kerberos bring full passkey options to enterprise apps? The answer to that is somewhat complicated. Matthew covers that in his response. They're sort of unrelated to one another. The fact that we have Kerberos in play gives us an opportunity to expose more functionality in that regard, but that doesn't necessarily mean that we will. There are reasons that we don't necessarily want to make Kerberos understand these protocols. There are potentially better protocols in play for this. OAuth, OpenID Connect are potentially better options for that. And they don't necessarily play well with legacy compatibility. Like, one of the things that we were trying to solve for here is legacy compatibility problems going back, decades. We can't necessarily drop new credentials on top of these applications. They may not work correctly. So in the event that you are wanting to use passkeys and things like that, these are not the changes that we're making here are not necessarily a direct route to that. You may want to consider other protocols like OpenID Connect. Let's see. Percentage of the difference. IACurb allow proxy Kerberos password. No. So IACurb is very much just a direct protocol between a client and an application server. This is not a generic Kerberos proxy. If you want a generic Kerberos proxy, we recommend using KDC proxy, which allows you to proxy all of those messages. Let's see. Is IACurb the same as PKEDU? No, they're totally different protocols. IACurb is an extension to Kerberos. PKEDU is just totally different. It's just an entirely separate implementation. It's an entirely different wire format. Everything looks different and behaves different. Entirely different code bases. Let's see how IACurb syncing will happen. How to manage if it goes wrong. IACurb syncing. Time drift. So time drift. A lot of people have it in their head, and that there are a ton of time failures that cause Kerberos to fail. At scale, statistically, it's an incredibly small issue. Most time issues in Kerberos are dealt with. We actually have a time synchronization process built into Kerberos itself. In the event that Kerberos runs into a time difference that is out of whack, we'll actually trigger a time sync so that we get the numbers in line with what both the KDC and the application think. As long as we can get an agreement on what those are relative to some fixed point, we don't have a time sync issue. The only time that things are totally out of whack and fail is if that difference is more than a few days, or I think we do like 72 hours or something like that. But if you have time differences that are that far out of whack, there are bigger issues that we don't really want to touch. Those are just Those are just scenarios that are broken. It's not something that we really want to fix because there are bigger issues in play. Other issues like offline servers tombstoning. I guess that's a domain controller issue, or you're talking about if a computer account has been disabled and deleted, things like that. We're still talking plain old Kerberos. You still have name resolution issues. As I was talking previously, those only make up about 7% of authentication failures. So it is a lot less than people think. These happen. They absolutely do happen, but fewer and far between. When will my deprecating NTLM is easy presentation? A couple weeks. I don't know. It's the blue hat people. It'll be out at some point. It will be out, I promise. Does this mean I don't need to worry about fixing up missing SPNs? No, you absolutely need to fix SPNs. That's a good. SPNs are good for you. They're like vitamin D. They guarantee that you are talking to the thing you want to talk to. They're like certificates in Windows or in over the internet. If you're talking to a web server that is giving you the wrong certificate, something is bad, and so you should have SPN set up correctly. Learn links. Matthew posted the links. Would iCurb allow you to request TGTs from arbitrary domains and not just for the one that the client computer belongs to? Yes and no. We're working through some hardening to guarantee that it can't be abused, but ultimately, yes. If that is there are ways that you can use this to get access to other TGTs. It is just Kerberos in the end. Will it be possible to authenticate via Kerberos from non-domain joint? That works today. You know, a lot of people have this assumption that non-domain joined machines cannot do Kerberos. That's just a flat out lie. Non-domain joined computers absolutely can do Kerberos. They do Kerberos all the time. My home computer, when I'm connecting over RDP to my work computer, my home computer is not domain joined to anything at Microsoft. It's my personal thing. I'm doing Kerberos. I'm doing PK init over that. It works. So yeah, it absolutely can. The difficulty with Kerberos is DNS name resolution, finding the right domain, finding the right realm, finding the right domain controller. If you have all of those infrastructure pieces in place, it just does Kerberos. How will server authentication work with the local KDC, especially if using the IP address instead of the host name? That's a good question. One of the funny things about local accounts is that they are fundamentally one of the few things in NTLM that actually do server auth, or at least some measure of server auth, because only you and the target server know the password that you're using. So the fact that the other side knows the password and can prove that it knows the password through the challenge response game means that it is who they say they are. In the IP address case and the local hostname case, we're cognizant of the fact that we have IP addresses and host names, and so we keep a running list of which IP addresses you're using, so that, for instance, if I connect via IP, it will route internally and will say, oh yeah, I know this is our IP, so it must be this must be for us. And so as a result, we'll do Kerberos. The scenario where this doesn't work is NATed environments. If I'm connecting to one IP and you have a router or a gateway that is changing the IP to something internal, yeah, that's not going to work. You should really consider using DNS in that case. Could the transition have a greater impact on SQL Server to failover? Maybe. Don't know. That's a great question for the SQL Server folks. Definitely worth raising with them. Over NAT, nope, covered that. Might local KDC be leverageable to better enable SMB file sharing between Azure AD joined workstations? Actually, it doesn't require NTLM. It actually uses PKUDU. That being said, we would rather people didn't use PKUDU from a holistic perspective. That's on us. That's something we need to change. That's not something we're ready to talk about yet. This definitely opens up opportunities for us to improve in that area, but that's not part of this conversation yet. What I see is a proper plan to deprecate NTLM for password-based authentication in favor of Kerberos for local accounts and domain accounts, but what about intra-ID accounts? Well, they don't use NTLM, period. They use PKUDU or OpenID Connect. For applications that have hard-coded ways of setting NTLM passwords for local user accounts, what is the prescribed way to set a local user password now? No change, same way. It's the database that holds all of your user accounts, the SAM, the Security Account Manager, that is ultimately the same thing that we're using with local KDC. All of the existing functionality, the net command, the existing SAM APIs, all of those work. We'll talk about threat modeling later.
So, yeah, we're up on the hour, so
okay.
I don't think we're going to be able to get through all these FAQ or the Q&A.
So many more questions.
Yeah, please email us if you have more questions or feedback.
There is one thing, if people, I know we're running over, I want to talk about this really quickly. There is one comment, why is MS still relying on Kerberos at all? Because Kerberos as a protocol is actually secure. There are a lot of fundamental security guarantees that we get with it that we fundamentally do not get with other protocols at this scale. There are issues with Kerberos. Those fall around weak crypto primitives. They exist in name resolution and SSO capabilities. A lot of those things are fixable, and there's a lot of things that we have simply done away with our local KDC, and there's a lot of things that we have already solved through our crypto agility work. And so a lot of the complaints that people have about Kerberos are not necessarily well-founded, and other protocols like OpenID Connect and OAuth and things like that simply do not work at a platform authentication level. There are just too many incongruities with how that protocol operates. Anyway, with that, Zach is yelling at me, telling me it's time to stop this presentation. Thank you, everyone. I hope you enjoyed it. If you have questions, by all means, Zach has the contact info up.
Yep, and we'll be compiling some of these questions and coming up with an FAQ, which we'll publish on our website shortly. So pay attention to that. Thanks, everyone.
Thanks, everyone.